start with that. We'll make it easy here. Okay. So my name's Abby Holovach. Excited to be here. I appreciate Monica inviting me, be a part of y'all's event. I'm out of Fort Worth, Texas, so I have my own business, Vibe Environmental, where I do all sorts of things under the sun of the environmental health and safety umbrella. So trainings, compliance support, inspections, audits, just a little bit of everything. So I love the variety of it. I have a lot of fun. Previously, I was also working for a hazmat and spill response company, as well as Holtcat, so environmental compliance manager there. They make all sorts of heavy equipment and machinery. Saw a lot at the spill company when it comes to health and safety in particular. Wrong ways to do things, right ways to do things. Definitely learned a lot. Also worked for a period of time at a joint reserve base here in Fort Worth. So I saw the federal perspective, and then I did see the state level perspective as well as an environmental investigator with the Texas Commission on Environmental Quality. So I've seen a little bit of everything. So hopefully you guys will walk away with some good real world helpful tidbits today. I do have a lot of critters. So those are just a few of my critters that you can see there. You probably will hear my chicken crow at some point. Harriet, we did not know he was a male when we got him as a day-old chick, hence why he's misgendered. But here he is 8 years later, so if you hear a weird noise, it's probably him crowing.
And so, sorry, Abby, so do you mind if I can record the session? Because some people is not going to join us and they would like to see the session.
Absolutely, yeah, please do.
Okay, thank you.
Yeah. All right, so that's just a little bit about me and who I am, but let's get into the meat. So why we're all here today. So we've got about an hour here together. So we're going to go through a little bit of everything when it comes to hazard communication, specifically in the lab and with what you guys do on a day-to-day. So as we said, if you have any questions or comments, I don't have any problem with you jumping in. If you want to share any, real world stories or real questions, please feel free to come off mute and jump in. We'll also have time at the end. But again, feel free to interrupt if you so choose and you have something you want to bring up. So, all right, let's get into it. Labels, SDSs, flammables, and how all of this can potentially and hopefully prevent injuries and incidents. So here's some of the things that we're going to cover. So first off, we'll start with HazCom, which is at the heart of our product management, how we label, how we identify, and how we communicate those hazards. We'll also look at safety data sheets, so SDSs. How do we locate this information? So let's say there's a new chemical that's introduced. We need to know what's going on. What are the hazards? How should we handle it? What PPE do we need? If there's been some type of spill, how do you need to respond? So we'll get into some SDSs. We'll also look at some general different hazard categories that are applicable to you guys in particular. So flammable liquids, for example. Dealing with a lot of solvents. So how do we safely store, dispense, and work with those? We'll also look at some hazards associated with things like sanitizers, compressed gases, and potential for incompatibles, reactive chemical combinations. And then we'll wrap up with some labeling, storage, handling procedures. So, what are some of the low-hanging fruit? Some of those issues that you guys can help with on a day-to-day that are within your control, not only helping maintain compliance, which is always important, but also just keeping you safe in your day-to-day, in your regular work. If we can keep these things in line and on lock, the better off everybody's going to be that's involved. So those will be just a little bit of the few things that we'll cover. A few rabbit holes we'll go down together. Okay, so of course you guys have a lot of unique risks when you're working in a beverage lab. So types of things you use on a regular. Food grade materials, of course. You're also using some industrial chemicals, though, and that's where a lot of our hazards come from. So sanitizers, strong acids, caustics, peroxides, so some reactive materials. As well as those compressed gases. So anything to do with carbonation, sometimes nitrogen. We'll talk about those. Those can be simple asphyxiants, which could be an issue if that's released in a small space. And then, of course, those flammable solvents like ethanol, isopropanol, solvents, etc. So where your unique risks lie is, again, confusing, or perhaps just assuming that food safe means hazard-free. Of course, though, we know that that's not the case. So even if something is food grade, it may still also be some type of industrial chemical. So we don't want to get in that false sense of security, thinking that because it's made for food and, R&D related to, something that people are going to consume, You're dealing with pure materials, concentrations that may be hazardous. So just because it's food safe doesn't mean it's hazard free. Could run into issues with cross-contamination between those ingredients and chemical workflows. There could be unlabeled mixtures. So as a result of some process, we want to make sure that those are properly identified as well, because those could pose some unique hazards. And then, of course, mindset shifts and how we look at our workspace, kitchen style versus chemistry style. So we may need to kind of be able to be flexible here. We don't want to have a lack of adaptation. We want to be flexible and be able to change and recognize those hazards and what may change associated with those hazards. So you guys in the R&D lab, specifically for beverages, of course, you've got unique work and unique risks, all things we'll talk about. So to start off, the globally harmonized system. So this is called GHS. This was adopted back in 2012. So prior to 2012, we still had, MSDSs, material safety data sheets. We still had labeling, etc. But the point of this was they wanted a standardized hazard communication system. So no matter what country you're working in, what supplier it's coming from, we should have this consistent hazard language, consistent pictograms. So across the board, there shouldn't be any confusion, no matter where you're working. So that was the goal of this back in 2012. So we've also got standardization when it comes to classification criteria. So what makes something flammable, corrosive, or toxic? Label elements, so things like signal words we'll look at, danger, warning. Things like pictograms, like what you can see on the screen here. Those are some of our most obvious indicators, as well as some hazard statements that give us essentially kind of the high points of why that material is hazardous. And then, of course, our safety data sheets. As I mentioned, used to be called MSDSs. That's now outdated. So if you hear someone still saying MSDS, it's because they're stuck in the old days, the olden times. So prior to 2012. But currently, we should all be using SDSs, safety data sheets. It is standardized 16-section format, used worldwide. So again, now we have a standardized system. We're all playing from the same playbook. So the goal here, once we learn how to read one GHS label, we should be able to read them all. So that's the beauty to this system. So OSHA and HAZCOM, so these hazardous communication rules, they're going to apply to all hazardous chemicals that you have in the lab. So again, food grade doesn't necessarily mean hazard-free. So some food grade ingredient hazards that you could be dealing with could have skin, eye, and respiratory irritation. There could be combustibility potential. There could be some inhalation risks, especially for powders, materials that may aerosol, and then sensitization and allergen cross-contact. All things that we can determine based off of a quick review of the label and a quick review of that safety data sheet. So HAZCOM applies across the board. Even if that material is technically non-haz, you're still going to have some type of safety data sheet. You're still going to have labels on it. So there's no exceptions here, except for obviously final products like a drink. But when it's in the lab, HAZCOM is going to apply, whether it's food grade, industrial grade, whatever it may be, HAZCOM is going to rule it all. So where things go wrong in the lab with HAZCOM, some things we'll continue to look at here together. So common issues, samples unlabeled, or they're labeled with cryptic codes. The goal here should be anyone should be able to walk in behind you and immediately be able to identify that material. There shouldn't be any question of what it is. Literally a person off the street should be able to not that they'd be in your lab, but if you get the point of what I'm saying, they should be able to wander in and immediately identify. There shouldn't be any question or confusion. Another issue we might see is chemicals transferred into beverage containers. Hopefully that's not too common of a thing, but it may be, where again, we've got some type of secondary container. We're doing some type of testing on it. Now it's in another type of beverage container. And again, we got to make sure that it's a proper container to begin with and it's clearly identified. Things like sanitizers could be assumed low risk because you use it every single day, or cleaning products. But again, in certain circumstances, larger quantities, there could be hazards there we still need to be aware of. So if you're working with that material, we should take a look at the label and we should have a review of that safety data sheet. Like it says, SDS is not reviewed for routine or well-known chemicals. There may be things about that material you didn't even realize. There could be chronic health hazards where you're being exposed to this material day in and day out. And if you don't take the proper steps to protect yourself, you could have long-term health impacts. So again, even if it's something we work with on a regular basis, if you've never seen the SDS, we want to make some time to do that. Also, things like compressed gas hazards could be underestimated, like carbon dioxide. It's familiar, but it is invisible. Could also pose potential issues, as well as other compressed gases. And then big one, new team members relying on what's called tribal knowledge instead of documentation. So basically, this is like that historical knowledge where you may hear things like people say, oh, everybody knows that's what we use that for. Oh, everybody knows that's where we put that. If that's the type of information we're conveying to new team members, that's not going to be solid. It's not going to be long-term and effective. So we want to make sure that any knowledge, information, steps, procedures that we're incorporating into our hazardous material management is documented. We're following a set of procedures. And if you're confused and you don't think there is a set of procedures yet, that's what your EHS contacts are for, is to help you make those determinations and make sure everybody's playing from the same playbook. So a lot of what we're going to talk about is hopefully designed, or it is designed, but hopefully it will help you close these specific gaps. So when we talk about GHS labels, globally harmonized system labels, this is what we're going to see on every single container. And these are requirements by OSHA, by the regulations. So there's no ability to remix or, make it someone's own. Very specific here. So first off, product identifier. What is the material? And that should be the exact same thing we see on the safety data sheet. We should see a signal word. So you may see danger or warning. If we see danger, it's more severe of a hazard versus warning, less severe. Hazard statements will be present, and sometimes this can provide us with some of the most helpful information right off the bat because it's going to tell us what makes that material hazardous. So it's going to describe the hazard for us. Then we'll have component number 4, those precautionary statements. So this is the stuff that, again, some high points that we need to be specifically careful of dealing with this material. Prevention, response, storage, disposal, conditions to avoid. All of those are important things to consider. And then last but not least, the supplier information like the manufacturer's name, address, and phone. So the big thing here, your responsibility, verify what's on your labels, what's on your containers. So of course you receive in a new container, new product or material, it should have all of these 5 components on there. If it's coming straight from the supplier, it's a regulatory requirement, so it should be there. Now, if we are having to transfer, we're using other containers, maybe ones you fill yourself, that's when we have to verify again, we take that extra step and we get it appropriately labeled. And we'll talk about secondary containers here in just a minute when you fill up a new smaller container to use at your workstation. So if we are having a situation where you're dealing with any chemical container and you can't read the label, it's missing, it's damaged, it's illegible, we need to consider that container out of service until that's corrected. So, there should be some type of area where in the lab or wherever you may be working, have a designated spot specifically for, hey, we found a container that's unlabeled. We've got an area specifically for those chemicals, and that way someone doesn't accidentally pick it up and start messing with it or using it. Set it aside until it can get rectified in a designated area. So again, we should always see these 5 components on every single product container that you deal with. Now, real world, this is what a label might look like. Again, may look a little bit different depending on the hazards and the manufacturer, but we're always going to have the same information. So number 1, we've got the product identifier. Again, matches that safety data sheet. In this case, in propyl alcohol. Then we've got our signal word. And again, danger means more severe. Warning is less severe. So in this case, danger, severe, we can see it on the alcohol label, and that's probably because it is so flammable and has some other dual hazards as well, like corrosivity and some sensitivity and health issues. Component number 3, our hazard statements. So again, this is always one of the most helpful components to read right off the bat. It tells us highly flammable liquid and vapor, causes serious eye damage, may cause drowsiness and dizziness. So for me, what I take away from that immediately is knowing first off, we're dealing with a flammable liquid and vapor. And if you know anything about flammable liquids, and we'll talk more about this, they want to become a vapor. That's just, how it goes when you've got a material that is a flammable material. It's got a low flash point, a low boiling point. It wants to become a vapor, which means if you're dealing with this material in an area where there's not great ventilation, It even says may cause drowsiness and dizziness. If inhaled, more than likely you're going to have some issues there. Again, not adequate ventilation. Maybe there's no vent hood going, or the vent hood's damaged, or it's not working. This is not a situation we want to expose ourselves to. We can deduce that right off the bat. As well as what kind of gear are we going to have on. It causes serious eye damage, so do we have the right PPE to protect ourselves, our eyes, and probably our skin as well. So we know we're dealing with something that's got some dual hazards here. So a lot we can deduce just based off of those hazard statements. Then we move to our precautionary statements. It gives more information here. How do we minimize or prevent adverse effects from an exposure? So first off, keep away from heat, sparks, open flame, and hot surfaces. You may also be dealing with issues like with some materials. If you are transferring, there may be a grounding and bonding issue because we can have static accumulation when you're dealing with flammables. Of course, things like no smoking. Hopefully you wouldn't be smoking in the lab anyways. Avoiding breathing fumes, mist, vapors, and spray. Like we said, it already told us it can cause drowsiness and dizziness. We know it's a flammable liquid, which wants to become a vapor. So again, that's how you could potentially be affected and exposed. Wear personal gloves or protective gloves, protective clothing, eye protection, face protection, and then what to do if it gets in your eyes. So high points here, the biggest things that we need to be concerned with. So again, take a minute, read your product labels, because even from these few pieces of information, we're already teeing it up for the things you need to be looking out for and how you need to be protecting yourself. Then, of course, we also have things like the supplier identification, so who manufactured it or who's the supplier. And then number 6, though, is one of our most obvious components, the pictograms. So it gives us specific hazard information visually. So that's what we can see, 3 different components here. So it makes it pretty easy from afar. We see those right off the bat, and we already know it's a corrosive. We see the burning hand. We see the flame. We know it's flammable. And we see the exclamation mark, which means it can be a health hazard. And we'll look at what some of those other pictograms mean here in just a minute. So again, that's the point of all this. Immediate hazard identification, and it's information you can immediately apply to protect yourself and protect your team members. So here are some of the hazard pictograms. So of course, a lot of these are pretty self-explanatory. We see things like the first one on the left, exploding bomb. You may see this also with some organic peroxides, depending on the material you're dealing with, where they're very reactive, very sensitive. Flame over circle, oxidizing gases, liquids, and solids. Gas cylinders, gas under pressure. Flame, we're all familiar with that one. We can literally see a visual flame. There's that exclamation mark we just saw. Acute toxicity, harmful, irritation, skin sensitization. Ooh, if I can say that word. Drowsiness, dizziness, which makes sense with what we just saw about that alcohol material, because it said if you inhale it, you're going to have a problem. So exclamation mark makes it pretty clear as well. Health hazard with the exploding chest. This could be a carcinogen. So if you're dealing with this material on a regular basis, then you want to make sure you're not going to be chronically exposed, because it could lead to cancer, mutagenic issues, reproductive toxicity. So these are things that actually can be passed down to offspring. So again, we see that exploding chest. We want to know why. Why is that one of the components? What do we need to be concerned with? Of course, skull and crossbones, that one's pretty self-explanatory. We've got an acute toxicity. So in this case, versus a health hazard where, it's more chronic with the exploding chest, if we see an exclamation mark or we see the skull and crossbones, we know this is going to be more of an acute issue. So you're going to feel it right then and there. You catch a whiff of it, or you huff it or it gets on your skin, you're going to have a bad time in that immediate moment. So of course, big red flags. And then things like corrosion, skin corrosion, burns, eye damage. We all know the burning hand. And then a non-mandatory one, but still important if, God forbid something happened, it got in a waterway, that's going to be an issue in terms of the environment. So aquatic toxicity. We may see the dead fish in the tree. So again, pictograms, one of our first clues. And a lot of times we get, we see these on our regular day-to-day, and so we get a little bit complacent. And so we're not actually using these as hazard clues to protect yourself. We just see it, we blow right past it, yeah, whatever. But you do truly want to take the time. What are these telling you? How do you need to protect yourself? And what are the red flags going to be if you do have some type of issue? Now, secondary containers, this is where we see the highest risk labeling gap, because we may transfer a material into another smaller container as part of our process. Even temporarily though, it does need to have identification on there as well. So of course, never using food or beverage containers for chemicals. Hopefully not. I've been to some like, shops and stuff like that, where they're doing maintenance and things, and they use all sorts of containers, pouring up antifreeze into old water bottles and everything else. So hopefully you guys don't have too much of an issue here. But nevertheless, we just want to make it, again, crystal clear what that material is and that there are hazards associated with it. So every secondary container, which again is a container maybe you pour up into, maybe it's a 5-gallon bucket, a 1-gallon container, some type of vials, etc. A secondary container is not the original, but it's something now that you filled up to use at your station through your process. So we still have some requirements here. We still need that chemical name. We still need some form of hazard indication, which could be a pictogram or one of these words, warning words, or if there is some type of concentration, if it's diluted, we would need to indicate that as well, like 50% acetic acid or whatever it may be. So we want to make it clear. Again, there shouldn't be any confusion here. So this would be a great example of where it was not done properly. Somebody used looks like almost an old, baby oil container and filled it with something and said unknown. And then it's also sitting in a food grade area next to some sugar. Another common one we see here was a drum that was reused. So if we are reusing containers, the label needs to match. Actually had old product labels still on it on the right hand side. You can kind of see it peeking around. It was for oil originally, and then they started to use it for soap. And in this case, somebody tried degreaser soapy soap, do not drink, which I would hope someone wouldn't use that, interpret that as a big long straw and start slurping. But you just never know. Again, we want to label these containers as if a random person off the street came in, had no idea what was going on. Are they going to be able to tell what this is? And if there's an uncertainty there, or your answer is no, we need to do something different. So to summarize what we'll see, primary container label, we're going to have the product name, we'll have those pictograms, there's going to be that signal word, danger or warning. Hazard statements, again, gives us in a nutshell what the biggest hazards are. Those precautionary statements in terms of handling, storage, what to avoid. We'll also see like the CAS number included a lot of times. But then the supplier information, of course, will be there as well. Then with our secondary container labels, much simpler, but we still want to make sure the information is present. So again, product name, we're communicating the hazards either through words or that pictogram. And then if there is some type of concentration, always a good idea to indicate it on there as well. So if there's a container that's within your work area or within your operations and it's not labeled either as a primary or a secondary, that's something we want to go back and we want to fix. And again, keep your eyes out for it. You may encounter these containers and you may not know what it is, but if we have a designated area where you can set those containers aside, put them in timeout until you can determine what it is, then we can get the proper labels on and out it goes back into operations. So great example here, phosphoric acid, 85%. So again, here's our primary label. It gives us the container or material name, phosphoric acid, 85%. It gives us the signal word here, danger versus warning. And of course, dangerous is higher hazard. Tells us through our precautionary statements that it may be corrosive to metals. We've got severe skin and eye burns, eye damage, keep in the original container, wash skin thoroughly after handling, etc. So a lot of this information, seems like, okay, no brainer, but a lot of times there may be things in here that we didn't realize. Now this one's pretty straightforward, but there are some where it says, do not swallow water as a part of the flushing. In this case, do not induce vomiting if you swallowed it. So, some things, again, we may not realize, but is going to be chemical specific. And we want to make sure we're well aware of what we're working with, especially on a regular day-to-day basis here. Now, when we are dealing with potential samples, test batches, we still want to make sure the hazards are communicated. So we still want to have product name or development ID, the date it was prepared, so we can know if these things have been hanging around for ages. Preparer's initials, so we know who started this process. And then key hazard information. So if it is a hazardous material, we still want to make sure that hazard is communicated. Because again, anybody walks up to it, they need to know what they're dealing with here. So if it is an alcohol, ethanol, isopropanol. Make sure we indicate flammability. If it is an acid or a corrosive of some sort, we're going to indicate that as well. If there are preservatives present that may be in sufficient quantities to be an irritant, toxic, also indicating that, as well as some of our concentrated flavor oils may be an irritant, could sometimes be flammable. So again, we don't want to assume because it's a beverage formulation that it's safe. So depending on what the material is, what concentration, you're going to need to indicate that material on that sample as well. So we want to look at our sample containers just like we would with our secondary containers. It's just a lot of times a miniature version. So still communicating the hazards, still making it clear what the concerns are, even with our samples and test batches. Now with our safety data sheets, we want to make sure that you know how to access them. So, if you're sitting here thinking, I'm not sure how to do that, then that's a good takeaway, is to talk with your EHS contacts. How do I access my SDSs? If I encounter a material and I want to double check what the hazards are before I start working with it, how do I go about accessing those? Because you're supposed to have access to them 24/7. That's a part of those HAZCOM requirements, those hazard communication standards under OSHA. So every material you have in the lab, there should be an SDS for it. So we want to review that SDS. Obviously, the first time we use that material, maybe there's a change in concentration. So now maybe it's stronger. Of course, we're going to have some, increased hazards here. After there's been some type of incident or a near miss involving that material, always a good idea to recheck it. And then again, if a new SDS shows up, we want to recheck it as well. So sometimes your suppliers may update safety data sheets. So if that was the case, if there's any changes with that material, we'd want to know that too. So looking at an SDS is not just for your EHS team. It's not just a one-time training task. It's a habit that you want to integrate into your processes. Because we may have this infrastructure here. You may have all these resources at your disposal. But if you don't use them, they might as well not be present. So we really want to make an effort to, where are my SDSs? Do I know what I'm working with on a regular basis? Have I reviewed the safety data sheet? And am I aware of the hazards? So again, 16 sections. This is coming straight from OSHA here. This screenshot, just kind of an overview of safety data sheets. So again, 16 standardized sections. Previously with your material safety data sheets or MSDSs, they didn't have these 16 sections. Again, there was not as much standardization here. So we'll look at a few of these different sections here. And sometimes the SDSs can be really long and it can be a little bit overwhelming. But if we take it chunk by chunk and section by section, depending on what you're concerned with, exposure, a spill, how to store and handle it, then this can become a wealth of knowledge. A lot of nuggets of gold here that you can use on your day-to-day work activities and your processes. To note, OSHA does not regulate sections 12 through 15, which is related to ecological information, disposal and transport, and some other regulatory info. Those are regulated by or overseen by other agencies like the EPA or DOT, etc. But sections 1 through 11 and then 16 are regulated by OSHA. So again, a lot of helpful information in here. So a few high points we'll look at. So section 2, we'll look at an SDS here in a minute together, but just breaking down some of the high point sections. Section 2 has our hazard identification. So this is very similar to what we'll see on that label. So what are the chemical hazards like flammability, corrosivity? Does it have any acute or chronic toxicity issues? So again, acute is going to be that immediate effect versus chronic is going to be a delayed effect. One of the most common examples of chronic exposures would be things like benzene, asbestos, where again, we're not feeling it right in that moment, but it's accumulating over time. And then that's how we end up with cancers and mesothelioma, etc. So again, very important that we check that out. And then of course, any environmental hazards. So a few common examples you guys might deal with would be things like ethanol, highly flammable. Certain types of acids, corrosives, oxidizers, going to be an irritant. Could be things like sodium hydroxide, sodium hypochlorite, severe burns, corrosive, toxic gas risk. And then of course, acids, also corrosive. So if there is a hazard listed, you start to read through the SDS and you realize, we're not prepared for that. Worst case scenario, we don't have any way to protect ourselves. Again, that's when we stop work authority, and you rattle it up the chain to get help. So you use your EHS contacts and say, here's this material we're going to be working with. I'm a little concerned. I'm not sure how to protect myself. Are our engineering controls sufficient? So when we say engineering controls, it's things like ventilation. Maybe you've got some type of monitors, for flammable vapors. Just depends on the process, but it's any of those things that are basically going to stand between you and the hazard. So again, if we're concerned, stop and get help. Then section 7, another important section for us. Of course, they're all important, but again, just some of the high points, things you might check out first. Handling and storage. So how do we need to store these materials? Is there a temperature we should avoid? What about ventilation requirements? Are there any incompatible materials where we do not want to put a strong acid next to a strong base, for example? That's how we end up with heat and vapor generation. What safe handling practices are specific to that material? So again, some materials may need to be in areas where, like intrinsically safe for some facilities that have larger quantities of flammables. And then shelf life, container integrity considerations. Again, just trying to make sure we're storing it right to begin with. So where we may see some issues in the lab could be, again, those strong corrosives next to your caustics and your acids. So acids and corrosives or caustics together, those two different types of corrosives, again, can form and cause an incompatible reaction. Same for oxidizers near organics and flammables. Cleaning chemicals, grouped by task. So we use these for certain activity, but you're not maybe thinking about, are they even compatible to be sitting on that same shelf together? And then, of course, flammables outside of those approved flammable cabinets. So a flammable cabinet is a great example of an engineering control as well during storage. So key principle here for section 7, storage segregation is not optional. It could be the difference between a spill and then a major reaction as a result. So we always want to think, what's the worst that could happen? What does worst case scenario look like? Let's review the SDS, look at our circumstances in the lab, and then again, if we have questions, rattle it up the chain and get some assistance to make those smart decisions. Section 8, always a big one for us, PPE and exposure control. So what gear do we need to have on when we're handling this material? So for example, what type of gloves? We've got a lot of different choices. Nitrile, neoprene, PVC, just depends on what that material is. Is it going to eat through the glove if we're dealing with it? What type of face and eye protection is needed, like safety glasses, a face shield, goggles? Is some type of respiratory protection required? What about those ventilation requirements? So local exhaust versus a fume hood. And then it also gives us a lot of our regulatory exposure limits and our industry standards for basically your EHS team to look at and say, all right, they're working with this material. Here's what they could be exposed to. Here's the limit they're allowed to be exposed to. And how do we prevent you from ever even coming close to that? So, common mistakes we might see, wearing the same type of gloves for every type of material. We have to keep in mind, especially with our PPE, it's never going to be one size fits all. A lot of these sanitizers, solvents, acids could break through standard nitrile gloves quickly. So again, we want to make sure we check the SDS and we look at what's actually in front of us. And are we seeing inconsistencies here? Red flag that we want to address. Section 9, this gives us a lot of information about how that material is going to behave. So those chemical and physical properties. So its flash point, how readily is it going to ignite? If there are a lot of vapors produced, like a lot of our flammable materials, that's a potential issue for a fire risk, of course. All it takes is one little spark or heat source and now we've got a problem. Boiling point, its behavior when heated. So if we're dealing with a material that has a very low boiling point, again, it wants to become a vapor. It's going to release a lot of fumes, relates directly to vapor pressure, how quickly it's going to build up in the air. That's going to be an inhalation for you, an inhalation risk for you if you're working with that on a regular basis. And then, of course, odor thresholds. We don't want to depend on, odor threshold as our sole indicator. Because a lot of times we can't smell the hazard until we're already overexposed. But again, it always, we want to use context clues. Something doesn't smell quite right. Again, that's going to be a red flag. Or all of a sudden you're smelling it very strongly. That's going to be a red flag. So not smelling anything is not going to be evidence of safety, but we can still use it as a clue. And Section 9 will tell us what that odor may be. So again, checking out Section 9 is going to give us a good indicator of how that material is going to behave. So for example, this is a phosphoric acid, 85% food grade safety data sheet. So you can see at the very bottom, there are 15 pages. So there's a lot of information here. But again, if we take it chunk by chunk, it's not as bad, and we will soon find that there's a lot of critical information in here we need to know. So right off the bat, of course, page 1 just tells us what that material is, gives us information about the manufacturer, as well as how that material should be used. In this case, industrial use, ingredient of food. Then we move to section 2. This gives us that hazard identification information, and we see right off the bat our pictograms. Corrosives, we also see that sensitizer. So we know we're dealing with a corrosive material. It also has health effects. Signal words, danger. So it's higher hazard because it is so corrosive. It gives us hazard statements like maybe corrosive to metals, causes severe eye burns, eye damage, and may cause respiratory irritation. So right off the bat, we know we're going to need to check out the PPE section, what engineering controls might we need to have in place, etc. Precautionary statements, always one of the first places we check out. So how do we prevent exposure? If there is some type of event in terms of response, what are we going to need to do? And then how do we need to store it? What about disposal? All of that information is summarized right in section 2. Section 3 gives us the composition information on the ingredients itself. So we can see we got 85% of the acid versus less than 15% of the water. So we've got a pretty high concentration here. We keep flipping through and we get to section 4, another important section. This is first aid measures. If someone does come in contact with that material, this is essentially an elaboration of what we saw in section 2, where it gave us a few of kind of the high points with health hazards, but this goes into great detail, whether it gets in our eyes, where we inhale it, skin contact, ingestion. So it gets very detailed here. And then of course it also goes into what about acute health effects versus overexposure, signs and symptoms. Indication of where they may need immediate medical attention. So this is what makes the SDS so important during an event, is because if someone is exposed and they do have to go get medical attention, a lot of times those first responders or those doctors, whoever's working on that patient may want to see an SDS. Let's see what we're working with here. We need to know the specific hazards and how it's going to affect that person and the outcome of their care. So again, just all the more reason to have access to your SDSs. If there is an incident, we can grab that safety data sheet, provide it to first responders, and then they can take it from there. Of course, section 5 goes into firefighting measures if there happens to be some type of fire incident, if there's some type of, hazardous thermal decomposition products, in this case, an acidic corrosive material, and any special protective actions needed if there is an incident. Section 6, what to do if there is an accidental release. Always critical to review. So first off, what are our hazards we should be aware of? Obviously not breathing vapor or mist, walking through the spilled material. It goes into if there is a small spill versus a large spill and how we need to neutralize that and clean it up. So critical information here if we're cleaning up a small spill. Section 7, handling and storage. So where do we need to store it? How do we need to handle it? What are some of the incompatible materials? Section 8 goes into exposure controls. All right, so this is what we talked about just a minute ago. If we are exposed, what is the limit that we're allowed to be exposed to in terms of OSHA regulation and industry standards? Also, what about engineering controls down towards the bottom? So if there is vapor accumulation, local exhaust ventilation, fume hoods, etc. So all of that is included in here as well. Section 8, okay, it just continues on here. So if we are going to, what gear do we need? Maybe that's a question asked. Section 8 will also provide that to us. So eye and face protection, skin protection, what respiratory protection do we need? And so you can see here it says recommended, for example, hand protection. Butyl rubber, neoprene, nitrile, PVC, etc. So not going to be one size fits all, but we want to confirm, is this on the list or not? Section 9 goes into our physical and chemical properties, so it gives us things like the odor. In this case, no odor. It's colorless. It's got a very low pH, 1 to 1.5. We've got a very high boiling point, so over 300 degrees Fahrenheit. So not a whole lot of vapor is going to be generated here. It also gives us things like vapor density, in this case 3.4, which if it's greater than 1, that's air, it's going to sink. Those vapors, if there was vapor accumulation. If it's less than 1, it's going to rise in the room. So a lot of clues here. We can determine if there is a release, where's that material going to settle? Or if we're just working with it on a regular basis, where's it most likely to creep and settle? Section 10, stability and reactivity. If there's any materials that may be incompatible with, of course, maybe corrosive to metals, no brainer. Section 11 goes into toxicological information, another tongue twister there. So this is starting with some of these sections where it's not regulated by OSHA. In this case, we've got some regulations by, things like EPA, DOT, etc. So actually that starts in section 12. Section 11 is still by OSHA, excuse me. So it's very long. You can see it continues on. Things like, is it mutagenic? Is it carcinogenic? What about reproductive toxicity? So maybe you're pregnant. This might be something you want to look at to see. Is this a material I should be working around? Am I sufficiently protected? Is it something that could affect, the growing baby, etc.? It also goes more into acute health effects, symptoms related to potential exposures. So if you start to feel funny all of a sudden, and now I'm feeling sick or I'm feeling, dizzy, you could go look at the SDS for that material you've been working with and see, is it listed in section 11 as a potential symptom of exposure? And you can kind of connect the dots here. Section 12 goes into ecological information. So this is where we start with some of the other regulatory bodies like EPA, if it gets into a waterway or affects the environment. Section 13 is for disposal. A lot of times this is one of the most or least helpful sections. A lot of times it'll just say follow regulations for disposal, which is not particularly helpful. Obviously, don't put it down the drain, no contact with soil, etc. Just helping and going, that communication with your EHS team, of course, is going to be the most helpful here and huge. They will direct you on how it should be properly disposed of, because a lot of times the SDS is not going to tell you. Section 14, this is DOT turf here, so we can see if it is being transported, all sorts of information, whether it's by ground, by air, etc. And then section 15, this has some additional regulatory information. Again, just some other regulatory bodies, so not as much helpful there for you guys. And then section 16 just has some other additional information. Sometimes you might see like an NFPA diamond here, but in this case, pretty simple. All right, so a few other types of hazard communication we also will need to look at. So we've looked at globally harmonized system, our labels, our SDSs. That's going to be on our containers. It's going to describe what the chemical does, versus another form of hazard communication we'll look briefly at, those DOT hazmat classes 1 through 9. So when you're actually in the lab, of course, we'll see the bottle on the shelf, GHS pictograms, hazard statements, etc. So it's the GHS world. But if it's something that's incoming from a shipment, this is where we may see DOT hazmat placards, labels, just more clues for what the hazards are. So if you can read those hazard clues from hazmat labels or placards from an incoming shipment, it's just giving you more information about the hazards. So a second layer of hazard information before you even open up the container. So these are our 9 different hazmat classes. We do have a couple different subdivisions here, but again, immediately identifiable information, color-coded. We've got the hazard class down at the bottom corner, and we've got pictograms. So we know right off the bat if we see a class 8 corrosive by color, white on top, black on bottom. We can see the burning hand, we can see the word corrosive, and we can see the hazard class in the bottom corner. So that also gives us a lot of helpful information. Maybe you've received new chemicals. Here they come into the lab. Pay attention to what hazmat labels are on those containers, because that's going to get you a start on what do we need to be worried about here handling this material. So just briefly going through each of the 9 classes here. I got 3 on the screen, of course. Class 1 explosives, typically not something you guys would have to be dealing with here. Hopefully it wouldn't be incoming at your facility, but you never know. Class 2 are compressed gases. There are some subdivisions here. Flammable gases, non-flammable gases, and certain types of toxic compressed gases. So for you guys, you may see things like carbon dioxide, nitrogen. So just because it's non-flammable or non-toxic, though, we still want to keep in mind those can also be hazards, because CO2, nitrogen, they can actually displace oxygen in the room. And if you're in that room, well, you're not going to have enough oxygen potentially to breathe, and then you could become asphyxiated. So Just because it's a non-flammable, non-toxic compressed gas doesn't mean it's without hazard. Class 3, very common one for you guys, flammable liquids. We'll see a red diamond with a flame. So this is like a lot of your solvents. And this is where flammable cabinets come in. Of course, never staging near oxidizers. That's an incompatible, or any ignition sources. Class 4, these are flammable solids. So typically something that, you guys probably won't see in your lab, but there could still be some food grade combustible dust in certain quantities. Things like sugars, starches, proteins, it may not actually be considered a flammable solid, but they can form a combustible dust if they're there in sufficient quantity in the air. So that actually can form a combustible situation. Class 5 oxidizers and organic peroxides, so things like peracetic acid, hypochlorite, hydrogen peroxide. Of course, want to pay major attention to this because we should never store those near flammables. Major incompatible situation. Class 6 are toxic and infectious substances, so skull and crossbones. So some concentrated preservatives, analytical reagents. You may see a class 6 poison come across your lab. And then the last 3, class 7 radioactive materials, probably not something you'd be dealing with. Class 8 corrosives, very common, caustics, acids, all sorts of things under the sun here across that pH scale. But this can cause some of our most serious injuries, of course, because they're very much an acute health hazard. And then class 9 miscellaneous, things like dry ice, lithium-ion batteries, even dry ice in a cooler actually can create the same asphyxiation hazards like CO2. So, again, pay attention to what classes you're seeing on your labels, on your markings, because there may be a lot of critical info here to get you started. So again, this is what we may see with the transport vehicle. Of course, we may see these smaller also on the individual containers, but it's providing us with clues right off the bat. We know we're dealing with a flammable liquid, or we know we're dealing with a corrosive. So, a few things you might see on your loading dock. Class 2, compressed gases, so nitrogen cylinders, carbon dioxide. Class 3 flammable liquids, ethanols, solvents, isopropanol. Class 5 oxidizers, those peroxides, hypochlorite. Class 8 caustics and acids. And then Class 9 dry ice, battery-powered instruments. So again, it's giving you a clue. Right before you ever even open that box, we can see what we're dealing with here. Then we know, hey, we've got some potential incompatibles here. We can catch errors before they become storage errors. And we can cross-reference, all right? We can see this label on the container. Let's look at the safety data sheet. Let's get the full story here. So your shipping label and your GHS label tell you the same story, just from 2 different perspectives. So we want to read both and consider both as part of our hazard assessment. Now, the third type of hazard communication you may see, touching on the NFPA diamond, called the 704, the fire diamond. So typically we'll see this on tanks, drums, storage areas, buildings, etc. And this is for our first responders to know what hazards they're dealing with right off the bat. So NFPA is for emergencies. GHS is for daily handling. And then those DOT placards and labels are for shipments. So different forms of hazard communication, but they're telling us a lot of the same information. So for example, we're going to have health, flammability, instability, and any special hazards. So it's always going to be a diamond. It's never going to be a square. It always has to be diamond oriented. Blue will tell us health hazards. Red is always at the top for flammability, and yellow is for instability. White has special hazards, and it'll have some special symbols and things we should pay attention to. And the rating system here is 0 to 4, so 0 being minimal hazard, 4 being the most severe. So again, numbered scale, all colored quadrants, always going to have red in the top, white in the bottom, a specific orientation. Some special hazards you may see, there may be a W that's in that bottom section. And usually it'll have like a cross through it. It tells you this reacts with water. Important for first responders if there's a fire. It may have OX for an oxidizer. Or for some of your compressed gases, you may see SA for simple asphyxiant, letting you know, hey, there's a material in here that potentially could push the oxygen out of the room. So in the lab, for example, you might see 230 for ethanol. Health hazard at a 2, a moderate. Flammability hazard at a 3 for serious. And then a 0 for reactivity. So minimal hazard there. But again, review the diamond, compare to what you're seeing on that DOT label, and compare it to GHS. And then now we're getting a full picture. So again, a lot of times we'll see these on buildings, tanks, sometimes on larger containers, but you guys probably see these on buildings most likely. So for example, 300 lets us know we've got something that has a severe health hazard, no flammability or reactivity hazards, but it is a simple asphyxiant. So major clue here for us and first responders. All right, so I know I'm going to run maybe a few wee minutes after the hour here, but we're coming into our last section. So flammable liquids in beverage labs. Of course, you guys deal with a lot of these. And the important thing to remember here is that more than likely your primary hazard isn't going to be the liquid itself. It's the vapors that are released. So ethanol, isopropanol, flavor solvents and carriers, methanol, all of those are going to be combustible or flammable. Now, flammable vapors are heavier than air, that vapor density greater than 1. So they're going to travel along benches and floors. And so if there is a large quantity or accumulation of that vapor, and there is some type of ignition source or heat source, that's where we end up in trouble. So again, when you're dealing with flammable liquids, keep in mind, it's actually the vapors itself that are going to be the most hazardous, not only from a physical perspective, but also for your health hazard perspective and what you're inhaling on a regular basis. So where we may see some of these risks come in, open containers. We're just allowing for those vapors to escape. We're dealing with hot plates, stirrers with heated bases. Again, if we're dealing with those materials and there's not control of those vapors, we may end up with a situation. Poorly ventilated rooms near recirculating air vents could pull that material and transfer it elsewhere. Cleanup of spills with paper towels that then sit in an open trash can versus proper handling and disposal in a proper container. So even small volumes can matter and can make a big difference. So 100 milliliter open beaker of ethanol, for example, in a small room can produce a flammable vapor concentration at head height, and then it'll start to drop down because it is heavier than air, but within minutes. So again, we want to pay close attention to our flammables, to our combustibles, and keep in mind some of the most hazardous components, the vapors, may not even be visible. That's why we have fire cabinets, flammable cabinets. Making sure it's closed when you're not actively adding or removing material. Limit the quantity outside the cabinet just to what you're using for that task. If you do have other materials like oxidizers, again, keep them separate. We want to make sure that you're aware of, looking at your flammable cabinet, have that discussion with someone on your EHS team. How much can we actually store in the cabinet? Sometimes there are quantity limitations, and so you don't want to just stuff it clear full. And then keep that cabinet area clear. Don't stack anything on top of it. Don't have materials around it. It should be its own individual unit with, some buffer zone around it in case something goes wrong, for access, all of that information. We want to make sure, again, it's easily accessible and kept clear. So again, ventilation. Can we work in an area with a fume hood? Well ventilated. Wherever practical, that's going to be our best bet to keep those vapors under control. If we are having to transfer flammable liquids, we're going to need some type of static control, grounding and bonding, using metal containers more than likely, avoiding poly and plastics because those can accumulate more static. Keeping away from ignition sources. Quantity control, like we said, don't have too many containers or large quantities sitting open. Only have out what you need. Never heating flammables with an open flame. Again, we may have those vapor accumulation issues. And then if there is some type of emergency, have we thought of worst case scenario? Where's the nearest fire extinguisher? Eye wash, safety shower, etc. So we always want to assess that with any of your operations in the lab. Am I ready for an emergency? Where's the closest spill kit? Do I feel confident from start to finish? And if not, make a phone call. Sanitizers and cleaning chemicals. So these are most of our corrosive materials. So another high priority. Peracetic acid, oxidizers, corrosive, also a strong respiratory irritant. Things like bleach, other caustic cleaners, acid cleaners. Some of our ammonia sanitizers could be irritants and sensitizers. So of course we know right off the bat you get corrosive material in your skin or eyes. May be painless at first, depending on the material, but you're going to feel it. So very much an acute health effect. We could see toxic gas generation if you have two incompatibles that are mixed together. Strong oxidizers could react violently with organic metals. And then again, respiratory irritation could be a potential here from mist, aerosols during applications. We're pouring up, we're combining. Again, ventilation is always going to be a key here. And then CO2 and compressed gases. So again, those class 2 compressed gas materials, even if it is something that's just like carbon dioxide, nitrogen, like we said, that could be a hazard in terms of oxygen displacement, asphyxiation. Going back to that vapor density, CO2, for example, is heavier than air. So it's going to settle down low, walk-in coolers, pits, small rooms. There could be a high pressure release. There could be elevated CO2 in the workspace. So I always say if you're working and you start to feel all of a sudden sick, nauseous, your head starts hurting, that's a red flag, especially if multiple people are feeling that, because there could be something in that environment like CO2 that's causing you issues and you don't even realize it. So it may be colorless, odorless, non-irritating. We may not even realize it's happening, but those concentrations are building up. So we do not want to underestimate the compressed gas component here. And then those incompatible chemicals, whether it's cleaning chemicals or chemicals that you're just using in general for your operations. Things like bleach and acid can create chlorine gas. So these are the types of things we hear when like people are cleaning at like restaurants or in their homes and someone passes away because of vapor exposure. It's because they're combining materials together that should not be. Hydrogen peroxide and organics, strong acids, strong caustics, bleach and ammonia, all of those can create either heat, those vaporous gases that can cause severe respiratory damage. So we want to make sure that, again, any container that previously held any type, even if it's not a cleaner, any type of chemical, does it still have residue inside? And if so, we need to stop and consider, what am I about to put in this container, and could it potentially cause a reaction? Even things like storage on the same secondary containment tray could be a spill. Now we've got two chemicals combining. So we want to be very careful with incompatibles. And there is a way to kind of double check what you're working with here. There's a couple different versions of this chart that's out there floating around in the world, but a compatibilities chart here. And it gives you not only your hazardous pictograms from GHS on the outer edge, it also gives you those DOT hazard classes. So we've got a couple different ways here to compare and contrast. So for example, let's say we've got a corrosive material. We go down to the bottom row, and we've got a flammable liquid material. So you can see at the top, where it's about the fifth one over to the left, flammable liquids. And we see where they meet. And it says 3 meters. That's how far apart those materials should be stored. So again, easy chart to utilize, but may be critical if you're dealing with a variety of hazard classes. So with those compressed gas cylinders, when we talked a minute ago just about, their inhalation hazards, but of course storing them, making sure they're secured, chained or strapped. That's one of the biggest things I always see at facilities is those bad boys out flopping around. Using the correct regulators, not forcing mismatched fittings. There is a valve cap, making sure that is kept on when it's not being used. Using a cylinder cart when transporting, we're not rolling, we're not carrying, and those containers are stored upright. And if they are full, keep those separate from your empties. And then, of course, no brainer, keep it away from heat sources. Add egress pathways. Again, thinking worst case scenario. So a few other lab hazards to keep in mind, and then we'll wrap this up. Dust and powders. So I mentioned earlier, it may not be, has a class 4 flammable solid marking on it, or label on there, but there still could potentially be a combustible dust component. Things like sugars, starches, in enough quantity in the air, that can actually cause a combustible situation, as well as an inhalation risk. You don't want to breathe that in. We've got pressurized systems, potential for rupture and whip hazards. We've got potential slip hazards, condensation around chilled equipment, spilled materials, heated liquids, syrups, processed streams. We could have thermal burns, like hot surfaces. And then, of course, ergonomic hazards, often overlooked, but still critical. Something you're doing day to day, and you don't want to hurt your back or hurt any other portion of your body if you are having to lift, move, and shift a lot of containers around. So when we talk about incidents here, there is some type of incident, These are typically the contributing causes that we'll see. Mislabeling or no labeling on your samples, intermediates, or secondary containers. Improper chemical storage. We're storing incompatibles together. We've got flammables outside of the flammable cabinet. Maybe we're mixing incompatible materials during cleaning, disposal, or just part of the general process. We're using old containers and don't realize there's residue inside. Skipping that safety data sheet review on those familiar chemicals. Again, it's something we see day to day. We see these pictograms, we see these labels, but take the time to actually review them. You're only going to do yourself a favor. Using improper containers like old bottles, unlabeled sample cups. Again, even with your samples, they should be labeled like a secondary container. Shortcuts driven by time pressure, production urgency. Again, people want to hustle and get it done, so they may skip some steps. As well as gaps in training. Again, going back to, where we said historical knowledge, that tribal knowledge. We don't want to rely on that. We want to make sure everybody's playing from the same playbook and we know where to get this information from. So if we can get ahead of these issues, of course, it's going to be cheaper, it's going to be easier, and far more effective than trying to respond to an incident in someone's potential injury. So common issues that we'll see, violations, again, missing labels, people not being able to access their SDSs, improper flammable liquid storage, so quantities, cabinet condition, segregation, maybe they're storing incompatible chemicals together, they don't have any HAZCOM training, they are not wearing or selecting the right PPE, and they don't have access to an eye wash or safety shower. So those emergency procedures. So all these things we've talked about, and every item on the list is preventable with routine practice. And again, if you're sitting here thinking in your lab, I maybe don't have this or I maybe don't have that, those are the red flags we want to notice now and act on them to correct them. So injury prevention strategy here. Label everything immediately before you set the container down, before you walk away. Again, should be any guessing games involved here. Review your safety data sheet before use. Be intimately familiar with that material. Check out what gear you need, what PPE for that specific chemical, not just generic, because it's never going to be one size fits all. Storing chemicals properly by compatibility, not convenience. Never mixing unknown or unlabeled substances. Like we said, if there is a concern, make that phone call before there's an incompatible situation. Pay close attention to your ignition sources, especially if you are dealing with those flammable or combustible materials. Keeping in mind things like static electricity, hot plates, heat guns, all of those things could be that component that's going to trigger a problem, a fire. And then if you do see an issue, speak up quickly. Like we said, a quick correction today prevents an incident tomorrow. So the sooner we can address it, the better. And you don't have to be an expert, but if you know when to wave the red flag and to get that help, that can make all the difference. So good lab practices as we wrap up here. Keep your work area clean, organized, and free of unnecessary clutter. Going to just make your life that much easier. Not reusing containers unless we've confirmed that's acceptable. Close those containers immediately after use. It prevents spills, prevents odor releases, prevents vapor releases. And then again, if there is a spill, consult the SDS, consult, your EHS point of contact. How do we need to address this? What gear do we need to wear? Am I even able to clean this up safely? And what do you want us to do with the waste? So we want to think these things through ahead of time. So dispose of chemical waste through a designated waste stream. We shouldn't ever be dumping or anything like that, throwing in the regular trash. And then, of course, maintaining awareness of what chemicals you even have in your area, in your workspace. Do we have SDSs? Do I know what the hazards are? And if there is a problem, again, report those near misses. That's how your team learns. So a few things in terms of inspection readiness. Like we said, hazard control and documentation is huge. Proper labeling, both primary and secondary containers. We can access our SDSs. Our storage practices and how we maintain our materials matches the SDS requirements. And flammable liquid control, we've got it on lock. We've got cabinets. We know how much can be stored in the cabinet. Everything's properly segregated, and we're not storing a bunch of boxes or other materials around the cabinet. And then, of course, some of those components we talked about with compressed gas cylinders, keeping them tied down, making sure the caps are on, and that those are being stored out of ways of egress or any other areas of operation. And then physical safety and employee awareness for you. You know what gear you need to have, and it's available to you. You know where your eye wash and safety shower is located, and it's being properly maintained. And employee awareness just in general. If someone pointed to you and pointed to the material you're working with, could you explain the hazards of what you're using? Could you explain what gear you should have on and what to do if there's a spill? And if you're wondering, ooh, gosh, I'm not quite sure, again, get ahead of it. Ask those questions now. Get it figured out now before it's a problem. So if your lab is ready every day, inspection day is just another day. And like we said, it's not always about inspections. Yeah, it's great to pass an inspection, but the big thing is your health and safety. And a lot of times it is within your control. So this stuff may be here for you to utilize, but do you actually know how to use it? So final takeaways here. Food grade does not necessarily mean hazard free. We want to check out those safety data sheet. What hazards are we dealing with? Could be based on the concentration, on that specific chemical, not necessarily the end product. So you guys are dealing with a lot of hazardous materials on a regular basis. Labeling is critical. Again, primary, secondary, and your sampling containers, clearly identified. Flammables, sanitizers, corrosives, strict everyday control. Again, just because we're familiar with it is not a substitute for a set procedure, a set standard that you have, and how you communicate those hazards. And then when we're dealing with compressed gases like CO2, again, may not be flammable, may not be toxic, but we still have inherent risk. Treat it with respect like the rest of the compressed gases. And then again, most of these incidents are preventable. Consistent labeling, safety data sheet review, proper storage, correct PPE. Ultimately, you're the last line of defense for yourself and the people that you're working with. So that's why we want to make sure you're an active participant in this process. And again, if someone points to you and points at a material you're working with, could you explain the hazards, how to protect yourself, and what to do if there is a worst case scenario?